We're asked to describe the end behavior of this function f of x. So again, I'd recommend this graphing tool, desmos.com/calculator. You can definitely do it without it, but for visual learners, it's really helpful to get a graph really quickly. Okay, so that's the graph of our function. And what end behavior means is it means what's happening with the function as we go really, really far to the right on the x-axis. You know, what sort of y values are we getting when x is really, really big? What sort of y values are we getting when x is really, really small? That's the end behavior of a function. So if we look at this graph, as x goes to positive infinity, look, the graph keeps going, right? And we don't see it at 20 right now, but if we kept scrolling back, eventually it would cross x equals 20, because look, you can put in any number you want for x. You could put in 20, you could put in 1,000. Doesn't break any math rules. We don't divide by 0. We don't take the square root of a negative number. So as x goes to positive infinity, the y values just keep getting huge, right? 4 to like a billion to positive a billion is a huge number. Times 5 makes it a little bit bigger. Subtracted by 8, that doesn't really do much in the end, right? As x goes to infinity, the y values go to infinity. So we'd say f of x goes to infinity. And now let's check it as x goes to negative infinity. This is just what's happening with the function as x goes towards the left, right? So negative infinity means you're thinking about the y values as x goes further and further back in the negative. So negative 50, negative 60, negative 70. Look, the y values are getting closer and closer to negative 8. And it's so close that now Desmos is just giving us negative 8 as its approximation. And the reason for that is because if you plug in a negative exponent, like let's start with negative 1, a negative 1 exponent is the same thing as the reciprocal. Okay? And so that's a negative 1 means we're shrinking this number. This term here is shrinking. If we have 5 times 4 to the negative second minus 8, the negative second means we're supposed to have 5 times 1 over 4 to the positive second. Now think about what that number is. 4 squared is 16. 1 divided by 16 gives us 0. So we're shrinking this number. As we go further back in the negatives, like 4... Come on, computer. 4 to like the negative 6. Let's try punching that in our calculator. 4 to the power of 6 as a negative is really, really small. So this term is getting closer and closer to 0. And then 0 minus 8 makes negative 8. So, based on the graph, and based on what we just did analytically with some numbers, as x goes to negative infinity, f of x goes towards negative 8. The y values get closer and closer to negative 8. So let me plug those in Mobius, because we know we said the y values are going to be positive. Oh, sorry, that's for as x goes to positive infinity, we said f of x goes to positive infinity. So Desmos should be okay. Not Desmos. Mobius should be okay with that. And then as x goes to negative infinity, we said the y values are getting closer and closer to negative 8. So let's just check that, just to make sure. Okay, there it is. So that's question 6, I think, right?